Hi, welcome to FoundedPy videos. This is DC here. This is the 5th video on Mifare application directory, and in this video I'm going to cover Mifare NFC sector. If you have not seen my previous videos, I would advise you to first look at those videos and come back to this. So this is the summary of all the things I have discussed in my previous videos. Now if you have seen my videos, by this time you know that there is something called as a MAT sector. This is the data stored in sector 0 for a 1K or sector 16 in case of a Mifare 4K. And the MAT consists of application IDs. The application IDs tells what type of application are stored in various sectors. And application ID consists of two parts, the cluster code and other is the application ID itself. And you know that the public key for MAT sectors are A0, A1 up to A5. And there is a NFC sector, and these sectors is where the actual NF messages are stored. The public key of NFC sectors are D3, F7, D3, F7 and so on. And you also know that the general purpose byte or the GPB in the MAT sector is stored in byte 9, and this tells you whether the tag has got MAD1 or MAD2. And also every NFC sector also has a GPB byte, and which we are going to discuss in this video all the possible values of GPB byte in NFC sector. So this is a bit of a background about what will be interesting to understand as well. So NFC Forum, if you're working with NFC tags and NF messages, you will come across the NFC Forum. So this is a consortium which standardizes and which gives more information about NFC. I'm going to spend more time on this. There are so many documents out there, you can get more information. So NFC Forum, to put in simple words, NFC Forum, they define the data structure. So they define how to store a URL, how to store a text, how to text a email, and there are so many types of information, so which is all described in the NFC documentation. Now NFC Forum also defines different types of tags. So you can have the type 1 tags, type 2 tags, type 3, type 4 and type 5. And all these above types of tags are accessible without any authentication or a pass verification. Now NFC Forum does not define how to store the data in a Mifare classic tags like 1K or 4K or a plus. So this is where what NXP has done is they have adopted these NFC data structures, and they have done a mapping on how to store NF messages in the Mifare classic tags. So I'll be referring to two application notes, and I would advise you to read those application notes. These two documents are very interesting, and this is something you have to read. So you have to read the first document, this one, and you can read, if you want to know something more about how to prepare or how to store the proprietary data and your custom data. But this is the most important document you have to understand, and every paragraph of this document is interesting, and you will is easy to understand document. So this is the summary of the first document I mentioned about. So after reading the entire document, you'll come across how the mapping is done, what are different commands that are used to read and write, and also the life cycle. And it also mentions about how the reader can recognize any Mifare tags with NF data. So it speaks about different states a tag can go through. So the first state is the unformatted or the production state. So this is the state of the tag when they're bought new. You know that all new tags, they come with the factory setting where the key A and key B values are all set to all FFFs. So these three settings are very specific to this application note. So the very first state, the tag goes is called as the initialize state. Now, so I've just had some information here which I have moved to a separate slide on its own. In the initialize state, then afterwards the tag can go to ReadWrite state, and afterwards it will go to the read-only state. Now these three states are very well documented in the application note. You have to know a little bit about this TLV concept. I've gone through this in my previous videos. It's just a brush up of the concept here. Now TLV is a tag length value. So there are many kinds of TLVs, but these four are the popular ones. And you have got something called end-of message TLV. Now this TLV consists of end-of messages, or this TLV format is used to store end-of messages where the value of the tag is 03. The length is the length of the end-of messages you have got. The value is the value your end-of message itself. There's something called null TLVs. These are used for padding. So if you're almost nearing the end of the sector, you can fill all the remaining bytes with the null TLVs and continue and have the entire data in the next sector. This is something the most developers will try to do, so as to simplify the coding. And also, if you want to make your end-of tag look neat. The null TLV will have the value of the T to 0, and this doesn't have the L and the V fields. Next is the terminator TLV, and this is the last TLV in a tag. So you might come across a tag which has got hundreds of TLVs with the hundreds of messages, but the only way when to stop looking for a TLV is as soon as you come across the null TLV, the terminator TLV. So there could be more empty space in the tag after the terminator TLV, so that is not considered at all. So the terminator TLV indicates the end of the message series. Now here the value of T will be FV, and this also doesn't have the L and the V. The proprietary TLV, this is something if you want to store any proprietary data. So in that case the value of T will be FD, and the value of L and V will be according to your data. Now every NFC sector also uses the value stored in the GPB. Now GPB is a byte in the sector trailer, and this is the encoding of the value stored in the GPB. The first 4 bits indicate the version of the mapping, and this is set to the version 1.0. so the first 2 bits here, the next 2 bits here, if you set the 0100, this is 1.0 version, and the last 4 bits they will contain the access rights of the data. So bit 3, bit 2, so these two will tell what type of read access that particular NFC sector has got, and the last 2 bits will tell you what type of write access that sector has got. Now, as mentioned here, if it's 00, it means read granted, 11 read not granted. Now I'm not sure how you can prevent somebody from reading the data from Mifare classic tag. However, so there is a value to indicate to application software that the data is not readable. So you might come across scenarios where, so assume that the entire sector is corrupted, or you are not using it. Probably you can just tell the application software that there's no point in reading this sector. So the write access conditions are stored as either 00, it says write granted, or 11 with no write granted. The other 2 values, 01 and 10, they are not used, and if it is used, they are considered as a proprietary type of setting. So here, so if you have the value of the last 4 bits with the 0000 here, it means reading is allowed, writing is allowed. If the last 4 bits will have 00 and 11, it means reading is allowed and writing is not allowed. Now to keep in mind, by just setting this to 1 1, the write is not prevented. If you want to prevent the writing, you have to somehow control that with the access rights, which you know if you have understood how the Mifare classic tag works. Now here's a bit of a theory, and we are going to see this all the things I'm going to show on a tag, but I would like to cover the theory bits before. Now the initialize state, what this means is you just have to write some data in the tag so that the software or your reader recognizes the tag as an initialized state. Say for example, initialized state means there is a MAD present and it has got at least one NFC sector, and you know that all NFC sectors will have the AID set to 0, 3 and E1, and this is explained in the annex of the MAD document. So the NFC sector will have a end-of message, but that will have the length of 0. So this also means it's empty end-of message. Now the GPB of NFC sector will be set to 40. Now we know that 40, the first 4 bits is the version, and the last 4 bits is the read and write access. We just saw when these two are 0, 0, it means both readable and writable. So there is a terminator TLV, it's a TLV, it's the not endf, it's a TLV. So there are 2 TLVs. The first TLV will have an empty end of message, and the second TLV will have the terminator TLV. Now the keys, the MAD keys and the NF sector keys are set to the public value, which I mentioned before, and the access rights are set as follows. The access rights of the MAD data block is set to 3, and the data block of NFC sector is set to 0. By setting to 0, now they become read and write, and by setting to 3 here, it's going to be modifiable only with the key B. And I've got 2 more lines here which probably can't see. So what I've got here is the sector trailer of both MAD and NFC, they're set to 4. Now by storing all this data and for all the sectors, you're initializing the tag. Now you can say that the entire tag is in the initialized state. The next is read-write state. Now here you can say the tag is in read-write state when it is initialized, and also the message that's stored in the NFC sector. Now there is something about end of messages which I'm not probably forgot to mention here. So there's something called as a mandatory end of message, or it's a very first end of message. So it is, to put in simple words, so it is the first message stored in the first NFC sector. Now assume that the first NFC sector starts from sector 1, second sector 2. The very first message that is stored here, now this is called as the first end of message, or is stored as a mandatory end of message. So sorry, I forgot to mention that here. Now you must have a message, or the first mandatory message must have a length which is not equal to 0. So everything that we mentioned in initialization state is still valid here. The only difference is it's all about the length of the message. The next thing is the read-only state. Again, everything in read-write state is valid here. It means you must have a message which is not equal to 0. There's no point in having a tag with the 0 message length. And also the GPB of the NFC sector is changed to F3. Remember, if you just consider the last byte, it will be 0, 0, 1, 1, and you know that 0, 0 is readable and 1, 1 is not writable, so it is set here. the access rights is set as follows. The access rights of data block in the MAD and NFC sectors, they're all set to 2. So 2 means they are unreadable, they're not writable. And the access rights for the sector trailer in both in MAD and NFC sector set to 6. This also makes the sector trailer block readable. Now if you write all the information into the tag and the tag is set to be in the read-only state. I think this is all what you have gone through. It's all the theory, and I'm going to show you now how to create this NFC sector, and you're going to understand better. If you go to the end of the first document in this NXT, there are a few examples showing the content of the tag in various states. So here what you see here is the one for the Mifare classic initialize state, and this is a very valuable information you got. So this shows you the content of the various sectors and blocks and flags. So since this is a Mifare classic 1, you can see the GPB is set to C1, and also all these application IDs are set to NFC Forum IDs. Now the application ID, what it says is I think the 03, probably E1 is NFC Forum, and probably 03 says all these sectors have got NDEF data. And if you look at this content of these NFC sectors, they all have the GPB set to 40. And if you keep scrolling down, there's one example for Mifare Plus with the 2K. Here you got because it is more than 1K, there are two MAD. One is a MAD 0 with here the GPB set to C2, and also now the sector, so NFC sector, sorry, have got a GPB as 40, and the MAD 1, which is stored in sector 16, has got a GPB as C2. So you can have a file with the content of the entire tag as initial data and use that to keep burning any number of tags. So probably this is one more example of 4K, and here also it's the same thing, just like 2K. Now with so much of theory, I'm going to show you how to create one tag with NFC data. I'm going to do this step by step, like I'm going to create manually without using any kind of a software. What I'm going to do is take a brand new Mifare 1K tag. I'm going to initialize, and I'm going to write a NDEF message that consists of a URI, and the URI is what is mentioned here. It is http slash colon 2 slashes www.definedpy.in. Now we are going to have, you have to have the mandatory NDEF message that is in the first TLV block, and I'm also going to use the terminator TLV, and we know the NDEF TLV has got tag is equal to 3, and the length is 17 bytes, and the value is where we are going to store the NDEF message representing URI. Now there are so many documents out there, and in fact if you want to know more about NFC data structure, I would advise you to read all those NFC forum documents. So in order to create a URI, this is what the structure of the NDEF message should be. The header is D1. Again, if you say documentation, you'll come to know what the D1 is. So put in simple words, I would say this tells about this is the there's only one NDEF message. This is start and end, and the type length is 1 byte long with the value 0, 1. The payload length, payload is the actual URL, which is 13 bytes. The record type is 55, and the actual URL is stored in the payload. So if you count here, if you count how many bytes you're going to store in the value block, you'll have 1, 2, 3, 4, and you got this. So you got here you got 5 and 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17. So all together the value will have 17 bytes, and for that reason we have got the value of L is 17. So I would advise you to look at some of the documentation or textbooks on NDEFs. And here what you have to know, one thing you have to consider here is, even though the URL starts with http:/::/ this entire prefix is represented by a code 01. If you have a HTTPS, you'll have 02, so something like that. So I've connected my A722U and I'm going to place a brand new Mifare classic tag. Now I'm going to activate, and here instead of typing everything, what I've done is I have got the entire tag content as a text file. I'm going to choose this 1K ndef init. Now this is the structure of the tag when it's initialized. Now if I have to initialize now, I can just go and write this in an entire tag. If I hit that, now this is a quick way of initializing or formatting a brand new tag. Probably if you have got something like this, if you want to make say hundreds of tags with the same content, probably you can just keep using this tool and can start burning entire tag. You can see here the content of this mad and everything is auto-filled with the correct values. The value of the CRC is right, and the values of the keys are right, the values of the GPB is right, and the access rights are right. And this is what the documentation says. In the initialization phase, you must have the MAD set to 443 and the sector, the NFC sector set to 003. So I'm going to reactivate. Now in fact you could have put the initial URL also as part of this file and you could have burned it, but we're going to learn how to create a NDEF message step by step. Now because it's already formatted tag, I'm going to authenticate. You can't hit this read entire tag. If you did that, probably what's going to happen, I know that most of the tag except the sector, except the sector 0, all of the sectors have got this as the key. I'm going to try to read the entire tag using this. If you can see here, everything except the sector 0 is right. So to read sector 0, you're going to choose this, authenticate, and read sector 0. Now when you initialize, according to documentation, there is a empty ndef file. So I'm going to replace that with the actual data. So I'm going to use 03, that's the tag for ndef, and we have seen that the length is 17, that's in the decimal, so it's 11 in hex, and which is followed by the header as see, we have just started to populate the value of the values for the value tag. So this is a T, L, and V. Now you just have to convert everything in hex. It's a D1, the header type length is 01, and the pay length is 13, which is in the decimal, that will be 0D, and the record type is 55. This tells it's a URI, and the actual payload will starts with the 01, that's HTTP, followed by the URL. So I'm going to go into the ASCII mode here. So we are going to populate B7. So here I'm going to type finite dot in and /. Okay, so we have just finished typing the finite pi.in, that's the URL. So you must have, so it's not you must, you can have a terminator TLV which is FE. So you just have to make sure that the length here in the TLV, the length is 17 bytes is what your return says. 1, 2, 3, 11, 12, 13, 14, 15, 16, 17. Okay, this is right, followed by this. Now in order to write to sector 1, you know that you have to authenticate with the key B. So which I know the key B for all these sectors are still SFFs. I'm going to choose sector 1, authenticate, and I'm going to write. So I have to write these two. Probably the best thing is I can write this entire sector. You can clear this and see what's the logs. So write. So you can see here we have written the block 0, block 1, and block 2. Block 2 was not required. We have done nothing to block 2. So we have just copied the URI into, or we have just written the mandatory end of message with the URI. Now how do we test this? I'm going to use this go to tags windows to make sure what we have just returned is working. So as soon as we place this tag, now go to tags software has got a feature that automatically opens up the browser with the URL. So it looks like the writing what we have done is working fine. So back into this software, there's a small feature that's been added recently. It's called restore to factory. Now we have a tag now which has got the key A value set to the MAD-A public key and NFC sector public key, but all the key B values are set to FFs. If you got a tag like that, you can reformat the tag back into the factory setting. If I hit this button, so probably now you don't see any success message here. So if you look at the commands, you can see so many write commands have gone in. So in order to write now, you have to make sure the authentication is done with the key B. If I clear this and if I say try to reactivate and read the entire tag, you can see that this tag is in the default factory state. So I would like to show you a few other features, some related to the MAD NFC. So I've got a file here that has got this one. Now this has got the structure, so that the structure that is that you'll get when the tag is made as read only. You can see here the access bytes, the access bits of all these data blocks and the sector trailer are set to 2. If you see what is 2 is for, if you look at this, the data block is set to 2. So here 2, it means it's a read only. If you look at the meaning of access at 6, it says nothing can be changed, key A can't be changed, key B can't be changed, you can just only read access bits. So I'm going to use this as well. Now we have got this as a brand new tag. Now I'm going to pause this video and populate. So assume that we have returned the URI in the NFC sector and we want to make this tag as read only. So I've just populated NFC sector with the data and I'm going to transfer entire tag content. Now say hit this write entire tag. Now this has made one NFC tag read only. If I have to use the same thing for many tags, I just have to place a brand new tag and just activate it and keep hitting this write entire tag. So we just made 2 NFC tags. I'm also going to make one more. So activate and write entire tag. So I'm going to make this file available to download. Please look at the comment section for this video. So along with this, I also got a few more data files here. I've got one for 4K. So you need a 4K text, and unfortunately I don't have many 4Ks to demonstrate. Now this is the content of all the 36 blocks, 39 sectors of 4K. Now this is an init state. If you choose the read-only state, you can see this entire 4K. So if you're preparing NFC tag is 4K, you just have to go here. It's not only just this NFC sector, you can populate data everywhere. And if you want to make multiple copies of this same tag, you can just keep placing a brand new 4K tag and just keep hitting this entire tag. So got one more sample files here. It's called this one. Now what I've done here is I have used only one NFC sector, and all other sectors are not used sectors. Now this is just an example to show that you don't have to have all sectors as NFC sectors. You can just have one, and probably as and when you add the applications, you can keep adding the more and more NFC sectors. So this is also there. So all these sample files it's available. Please look at the URL. So probably now we have covered enough in this 5 videos. We started with the MAD. We understood the MAD structure, and you learned about the NFC sector, and we just wrote a simple URI. So I hope all these videos are helpful to you, and probably you can take this knowledge further. Thank you.